There's a new kid in town, and man, oh man, is he impressive. This printer is made by a company called Mingda. I have never heard of this company before. They're obviously a Chinese company, and we all know that there's a very, gray line. It's not a hard and fast line between the Chinese Communist Party and all of the companies in China. So what does it mean to see a new name on 3D printers coming from China? Probably doesn't mean that much. It's probably coming from the same factory as, I don't know, the Tevo printers or something like that. But it's nonetheless extremely impressive. And looking at this thing, which has the same build volume as an Ender 3, that being 235 by 260 millimeters, nobody, and I mean nobody, should ever buy an Ender 3 printer ever again. This is the same price as most people pay for an Ender 3. $235 with free shipping coming from Amazon right now. I think there's a website, it's like crealityonline.com or creality3donline.com or something like that, and you can maybe get an Ender 3 for $180 there, but I don't know about shipping. Once they add in shipping, I bet you're going to pay the same price as this printer, $235. Just an incredible bargain. This thing is so much better than the Ender 3. It's got this whole enclosed base. It's got these wider rails so that the bed doesn't have any play in it. It's got dual lead screws for the Z direction. It's got 20-40 extrusions wherever there are extrusions. It's super rigid. And it's got a great touch screen. I think it's running a 32-bit processor and trinamic stepper motor sticks. So for the newbie out there, all of those things aren't going to make much sense to you, and they don't need to. This video is for you. Just follow along. I'll show you how to get this thing out of the box. You're seeing the fast forward footage there. And after that, we'll put it together, and then I'll show you how to run your slicer software to get your files ready for printing on this printer. And spoiler alert, it makes prints straight out of the box right here in its stock condition. It makes prints which are as good as the Prusa Mark III, which is a $750 kit, and that takes you 9 to 20 hours to assemble, or you can spend $1,000 and get the pre-assembled Prusa. So for $235, you're getting every bit as good of prints as you get from the Prusa. Straight out of the box, no modifications necessary. But that being said, take a look at this channel. Next week, I am going to do the more advanced video on this printer where I fully dissect it and do the modifications that I think it needs to be upgraded to really get it to be, the best kind of printer out there. Similar to the, what I've done, the treatment I've done to the Ender 3 previously. Check out this video here if you want to see a very impressive Ender 3. All right, without any more delay, let's teach the newbies how to print for $235. All right, so here's everything that comes in the box with the printer. There's this SD card and an SD card reader. Look at that thing. No doubt that the instruction manual for assembling the printer here is included on the SD card, but it's so easy. You don't even need the instruction manual. The first step is to install these T-pieces like that right there, and you use the short screws here to go into the lower portions and the longer screws like this one to go into the upper spots there. The next step is a bit of delicate surgery. You've got to balance the screw on the end of your Allen key and get it in that hole all the way up in there and screw it in to the bottom of this upright. Can't believe I was able to get that on camera. Now connect these two wired plugs, and then these two little black wires connect onto this limit switch right here. The final wiring job is to connect all of the stepper motors with their respective plugs, like so. Now use these 3 bolts to attach the extruder X carriage thing to the actual movement trolley. And the last thing you need to do is use these 2 JAS Phillips style screws to attach this cover plate like so. And for the one person out there who still uses QR codes, I'll put that one on the screen just for you. And then I'm going to take it off. Much better. All right, you guys, now we need to jump on the computer and get our first file ready to print. And it's a pretty easy process, but we have to first install a program called a slicer or a slicing software. And we have to turn a CAD object, which is an STL file, into a instruction set, which is a .g code file. And the instruction set is just movements. Move here and extrude this much filament as you're moving. So the instruction set is .g code. And what you can see in the folder right here, this is the SD card that came with the printer. You can see a G code file or folder, which is basically the manufacturer giving us 5 prints that we can just start printing without ever having to open up a slicer or learn how to do that. But they also included some geometry for us, which is nice. And you can see this 3D benchy geometry. They did not include that one. I had to download that from Thingiverse. And you can see it right here. It's this green boat. And it's just, for whatever reason, it's become the standard first test print that people do. Probably a Prusa thing. Most of these, things are, originating from Prusa. That's the popularity. They've, they got their online presence. They're real strong. Might be a sock puppet farm. We don't know. But they tend to manipulate and control the narrative with 3D printing. And so 3D benchies loved by Prusa, and the whole internet now think that's the standard thing, but it's terrible. As a father of a 3-year-old, I hate this model. It doesn't float. It flips upside down and sinks. So my kid loves it because he's like, "Oh, a boat," and then it just doesn't work. It's so disappointing. I think the better thing to do would be to use this one here, which is supposed to float. But we're gonna go with the classic benchy just because I want to show you guys in comparison to other printers how good this printer is. And there's lots of benchy models and photos of other people's successful benchy prints out there. So we're going to go with this one. And like I said, I already downloaded it. So we've got the STL file. We need to convert it into the G code file. And the way we do that is by using a slicer. And that slicer that we're going to use is Cura. Now, full disclosure, you guys, I don't use Cura. I use Simplify 3D. Like a couple of years ago, I paid my $150. I don't know what the price is now, but I paid my money and my license has been active ever since. And it's just honest. I paid my money and I got a slicer that's no BS. It just works, and it works quite well. With these other slicers that are free, they get you somehow. Like, we're going to get into this, but Ultimaker is a company that sells a 3D printer, and they also make this free slicing software, and they kind of want you to use their printer. And so there's ways that the program tries to steer you into Ultimaker's ecosystem since they've got you at the slicer. So, you get what you pay for. And if you didn't pay anything for your slicer, it's good. It's well liked. And there's plenty of tutorial videos out there. I'm not going to go crazy into it. But the bottom line is that you can go right here on the SD card and install Ultimaker Cura 4.1. And you can then use this PLA plus Cura profile, and everything should just work. You should be able to then go back to your STL folder and just drop your STL geometry into Cura and pretty much press slice, and then upload that G-code file onto your SD card, put the SD card in the printer, and print. It should be that easy. But I'm not going to do that, and I'm going to tell you why. First of all, there's a newer version of Cura out there, and generally speaking, newer is better. And second of all, I have trust issues with Chinese software. We all know that the Chinese corporations are this far removed from the Chinese Communist Party. We all know that the Chinese Communist Party is trying to take over the world, trying to spy on everybody, even worse than our own country. Like, they have that, social credit score, so I wouldn't be surprised if they've got a ghost social credit score for many Americans. Like, they've got a naughty and nice list for Americans as far as they're concerned. And so I've downloaded Chinese programs before, but I don't trust them. So here is a .exe file for Cura, and I'm not going to click on an executable if I can avoid it. So thankfully I can avoid it because I can download Cura directly from the Ultimaker website. Just look up Cura on Google or Dogpile or Bing or whatever your search engine is. And then you can download it for free. And I've already done this, and I've already installed it, and here we are. Now, when you install, what I suggest you do is use the Creality Ender 3 as your base printer. It will upload what you're seeing here, and the Creality Ender 3 has a build volume of 235 by 235. Now, the Mingda printer is 240, so it's slightly larger. You could use this as your starting profile, But why would you when you can download the profile from me? So to get that, just follow the link in the description down below. And once you have it, here's how you load it. You go to Preferences, Configure Cura. You click on the Profiles tab down here on the bottom left, and then you click Import. Then you just select the profile which you've downloaded from me, click on Open. Okay, and then you click on that actual profile and select Activate. And there you have it. So now you click on this little folder, like up over there, somewhere up there. Click on that folder icon and you select your geometry. Click Open and it will appear on the build plate. Now, in this instance, I want to rotate the geometry 180 degrees. So I'm going to come over here. First I'm going to click on the geometry itself. Then I'm going to click on the rotate icon. Then I'm going to grab the blue line here and drag it until the thing says 180 degrees. Right there. And the reason I want to do this is because my part cooling is coming from only one side at the moment, and I want it to cool under the bow there. That's kind of the important moment for part cooling. So now we're pretty much ready to go. Click the slice button. You can click the preview button here, and on the right-hand side, there's a slider. And you can slide. So using the shift button and the right mouse, you can move around. Let's unclick this so we're not trying to rotate anymore. And let's not click on this either. I don't know. I don't know how to make all that go away. Anyway, you just click on the screen anywhere randomly. So hold the shift button down and then right mouse allows you to drag. So right mouse can also zoom around. So that's how you can kind of navigate the window here. And once you're in it, you can use this slider just to see what each layer is going to look like. So you can see this is going to print the name that whoever made the model included. So we'll go back here to the, we'll click on the model again. We'll go back here to the movement. There's moving. And we'll move it in Z by -0.2 millimeters, which is one single layer height. And then we'll reslice it. And ta-da, we don't have that name popping up anymore down below. So there we have it. That geometry has been sliced and it's now ready to print. Now you can just click Save to Removable Drive. If you have it automatically set as Save to Removable Drive, you would probably want it to save to File. And when you click that button there, it asks you to navigate to the specific drive. I like this Save to File function better than Save to Removable Drive. They're just trying to make it like one-click saving, but to me it's more cumbersome and more trouble than it's worth. Before we move on, I want to just sort of point something out. This is a bridging test. That's what this is called, right? Where it's kind of printing into the open air. There's an archway there, but there's a big flat spot across the top. And bridging is something that 3D printers can do. It gets harder and harder the thicker the extrusion. So if you're using like a 0.6, 0.8 millimeter nozzle, bridging gets really bad. But with a 0.4 millimeter nozzle and good part cooling fans, you can get good bridging. So this is possible. But you see a 45-degree angle, building up at a 45-degree angle with an overhang of 45 degrees is possible to get fantastic looking prints. But after you get over 45 degrees, things start to get dicey. Now you might be able to get to up to like 60 degrees depending on your cooling and all of that. But if you'll notice, this last layer right here before the bridging moment is hanging. There's a long bit of overhang that hangs and kind of doubles back. It doesn't bridge across the whole span. So I just want to point that out because it's going to be relevant later on how this geometry is sliced. Because later on, I think that this is the smoking gun, and we're going to see that it's not this exact geometry that Prusa is using. Anyway, I'm going to save this to the SD card and put it in the printer. Now we need to level the bed. What I like to do is to level each side using a credit card. So I get the thing pretty close to where I have to bend the credit card a little bit. See, it's bent in order to kind of fit underneath the side there. And then what I do is I reach around the back and I'm grabbing this is the collar that holds the lead screw to the stepper motor, and I'm spinning it right there. I'm spinning it ever so slightly until the credit card falls. So just like this, until the credit card moves right there. Then I do the same on the other side, but I hold the first side because I don't want this thing to move while I'm moving this. They tend to move together, so you got to kind of keep one from moving. There we go. So that's just my way of leveling the moving X gantry, movement rail there. And once that's level, now we can go on to the bed. So down here in the menu, we're going to click Home. All right, that nozzle is now down at the bed, and the important thing is that the nozzle is up to temperature because you don't want to have a hardened, like, globule of filament throwing off the feeler measurement with this paper. So now you go to the movement menu, and you can see we're at Z0. So let's lift up Z10 just to get us off of this moment. You can see I've leaked a little bit of filament out, and then we'll go X10, and then Y10. How about X20, Y20? So there we are, X20, Y20, Z10. And what we want to do now is to go Z0. And you can see that my paper is catching. So I'm going to spin this knob here until my paper moves freely. But just ever so slightly, a little bit of friction. Same thing on that side. Also, I think I forgot to mention, but it's good to have both the nozzle and the bed up to temperature when you are leveling it. And the reason is that the bed can kind of warp and change shape as it gets hot. So you want to level it with it at temperature. In this case, it's 60 degrees on the bed temperature because we're printing with PLA, and 200 degrees on the nozzle temperature. And one other thing I want to correct, I said that the measurement on the bed was 240. Well, that is 240 on the magnetic piece, but the actual print size is 235, so it's exactly like the Ender 3, same dimensions. It's just that this magnetic piece overhangs a little bit. So watch my last video to talk about print surfaces. This one will work really well for PLA, but if you want to print any other materials, I really don't like this, and you should upgrade. We're almost ready to print now. You should buy a roll of filament with your printer, or get it from some other source when you get your printer, because the tiny amount of filament that comes in the box is not going to be sufficient to do anything except maybe like one benchy or two at most. Anyway, you load your roll of filament in. You make sure that you feed the tail through the what is this? The filament runout detector. So when the tail actually feeds through there, well, I just snapped that. This is some old wet brittle filament. We'll see how it does with this benchy test. Here's something else you need to do in order to help it feed, is cut a sharp point into it. And then you should be able to get it through both this part here as well as the part down below. And I'm really struggling. You got to try to straighten it out without breaking it if you've got brittle filament like me. Just give it a little bit of a bend until it's straight. There we go. Oh, and of course, as soon as I get it through, I pull it back. There we go. And down here, going to be a similar deal. All right. And then you basically squeeze that lever right here down so that you've released tension and you're allowing it to feed through. And you feed it through until it's running clear. So you basically don't want to have, I like to pump it back and forth a little bit. It just helps clear it out. So you basically want to feed it through until you don't see any of the previous color. If you guys can tell, I was printing with black in the last print. Okay, now that that's done, we come to print, G-code, and there's our 3D benchy right there. Select it, and it's going to start printing. By the way, this is a meter, tells you how far along your print is, but this really is just a measure of how many layers it's done. So if you have a pyramid shape, the bottom layers are going to take a lot more time than the top layers because they're going to be very small at the top. So this will be an inaccurate gauge because the closer you get to the top, the faster it's going to go. But this does not reflect that. It just reflects the number of layers that have passed. Okay, try to keep this clean a little bit. I just like to help the printer out. I just kind of keep keep the stuff out of there. You can also use your flush cutters and just sort of yoink. It just helps. Now you can see what it's doing is it's laying down what's called a skirt. And that just means it put 2 lines around the model at the outside edges of the model. So this is not going to touch the actual model of the print. So this right now that just started, that is the real print that's now beginning. And so we got 2 outer walls, and then it's going to infill across the bottom. All right, in like an hour and 10 minutes, this thing will be done printing, and we'll take a look at it. I do enjoy the RGB light show of this printer. It makes it kind of mesmerizing to watch the thing work. Kind of fun. So one other thing that I want to note before this print finishes is the angle of the part cooling fan here. So you can see I've bent this bracket out slightly, and this way that part cooling fan is blowing right at the tip of the nozzle, right where it's laying down filament. Now this needs to be worked on, and I will be making some new geometry for both of these fans to be mounted here, because that is too much of a distance, and it's also only cooling from one side, and also the angle is wrong. So anyway, if you get the angle right just by sort of bending this out, just grab it and bend it hard, and it'll do just fine. Then you'll get good part cooling, and you'll get a nice print like what we're looking at right here. Also, obviously, I've removed this cover plate. There's really no need to have that there, and in fact it's just extra mass to be moved back and forth on the printer, and that's called inertial mass, and it's something that we want to limit. So let's just peel this magnetic print surface off, give it a little flex, peel that benchy off and take a look. Looks pretty darn good, you guys. Get a close-up here on the main camera, but yeah, that looks as good as anything I've ever seen on the internet. These strings here, you can alleviate the stringing. There's some tricks to that. I've got a video actually on the subject. But yeah, it also has to do with how wet and how old your filament is. Let's take a close-up look at it and compare it to another one that another YouTuber recently made. The most notable quality issue with this print is these gaps at the start of each layer where it's just not extruding correctly, and that is originating from the slicer Cura. This model here I sliced with Simplify 3D. I didn't show this one because of the slicer, but you can see no gaps. So it's something I should be able to fix in Cura. Anyway, the other quality issues of this print are pretty negligible. The overhangs look really good. Part cooling's actually doing surprisingly well. The stringing is not too bad. We talked about that a minute ago, but really pay attention there to the tops of the doorway and the tops of the windows, and just see the good part cooling, see the quality. And we want to compare that to this model here by the YouTuber This Old Tony, who recently paid $750 for his Prusa printer, and this was the model supplied to him by Prusa. It came on the printer, so he didn't even slice this himself. This was given to him by the pros, and just look at how ugly that window is. So you see the ugliness there on the right, or on the sort of on the top in this angle. But really notice there's a flat spot across the top there. That's bridging. And back to what I was talking about earlier, I think Prusa's cheating here, and they've modified the model so that it's bridging there, just to make it look a little bit better. So I went this whole video with using this screen with the screen protector on it. I didn't need this. I could have pulled this off a long time ago and gotten a much more clear picture on the screen. Now it is a little bit wedged in there, but we'll get that off. That's much better. Just wow, you guys. About the only thing negative that anybody could say seeing this video is that those layer lines aren't right. And I don't know what that's coming from. I'm not intimate enough with Cura to know which setting I need to change to get that to go away. But I am really quite well versed with all the ins and outs of Simplify 3D, and you've seen that issue does not manifest here on the Simplify 3D slice. So we know it's not an issue of the printer, it's an issue from the slicer, and I'm gonna get it figured out and get you guys a really good Cura profile to go along with this printer. So look for that in the description down below. And you'll have a printer, if you buy this and get my profile, you'll have a printer that's every bit as good as the Prusa, the $1,000 or $750 Prusa, let alone the Ender 3. Just phenomenal. Phenomenal. Now, the only other printer that I've ever seen kind of in this vein is the artillery sidewinder back there, and I'll talk more about it, more like in depth about it next week when I do the advanced video about this printer. But let's just suffice it to say that they cleaned up the interface, the electronics are a little bit better, and they got us those dual stepper motors for driving the Z-axis, which is, I like it. I like it a lot. So I'm super impressed. I can't believe they were able to squeeze this much value into a printer for this little money. Just amazing. Well, that'll do it for this video. Thank you for watching. Here's another video that Google thinks you want to watch, and if you like what I'm doing here and you want to support this channel, click there, and I would really appreciate it. So thanks for watching. See you next time.